Analysis of fats and oils. Here we are analyzing the fats and oils based on some constants and values to determine their quality of the products of the fats and oils. The first constant we are going to discuss is acid value. Acid value or acid number is the index of acidity. So this acid value is used for determination of acidity of a fat or a oil. It indicates the amount of free fatty acid present in an oil or fat, used to determine how much amount of free fatty acid present in a oil and fat. The acid value is the measures the breakdown of triglyceride into free fatty acid due to hydrolytic rancidity or bacterial action and chemical treatment. So the because of rancidity, the fats are undergo hydrolysis, then it will be produce some amount of free fatty acid and glycerol. How much amount of free fatty acid generated due to this hydrolytic rancidity and due to bacterial action we are measuring. So those have adverse and undesirable effect. Whatever the reaction, the hydrolytic rancidity, they are having some undesirable effect and it will be produce the rancidity of the fats and oils. So the definition of acid value is defined as the number of milligrams of KOH required to neutralize the free fatty acid present in 1 gram of fat or oil. So when we are taking 1 gram of fat or oil, how much amount of fat is degraded or rancified into a free fatty acid or and glycerol. For that purpose, how much amount of milligrams of KOH is consumed or required to neutralize the acid produced due to the rancidity. The procedure of determination of acid number or acid value. First, take weigh accurately a required or known amount of fat or oil in a conical flask. Then add 50 ml of ethanol ether solution. Shake it well. To this conical flask which is having the fat, to this we are adding a 50 ml of ethanol and ether solution, nothing but organic solvent. The contents of the conical flask is titrated with 0.1 normal potassium hydroxide using phenolphthalein as indicator until pink color is obtained. So upon the titration in between a carboxylic acid or free acid with the potassium hydroxide in the presence of phenolphthalein indicator, so the completion of reaction at the end point is determined by change in the color to colorless to pink color. Then we are calculating the acid value by using the formula is how much volume of 0.1 molar KOH is consumed for neutralization of the produced free acid into 5.611 by weight of the sample we have taken. So this is the formula for determination of acid value. If the acid value is more means the more amount of triglyceride is undergo rancidity. So the more amount of free fatty acid are generated due to this rancidity. Saponification value. The saponification is nothing but hydrolysis of a ester under alkaline conditions to a carboxylic acid and alcohol is called as saponification. So here the ester is nothing but the triglyceride fat. So when this fat undergo hydrolysis under alkaline conditions, so in the presence of KOH or NaOH, when the ester is undergo hydrolysis, a complete hydrolysis, that time it will be produced a fatty acid is nothing but carboxylic acid and alcohol. The produced acid is then react with the KOH to form a soap. So what is the exact definition of saponification is, it is defined as the number of milligrams of KOH required to neutralize or saponify the free fatty acids or carboxylic acids generated by the complete hydrolysis of 1 gram of fat or oil. If you are taking 1 gram of fat or oil, to this if you are adding KOH, that time a complete hydrolysis of fat will be done. That time it will be produced the free fatty acid. So how much amount of free fatty acid is generated upon complete hydrolysis of a specified or required grams of fat or oil is called as saponification value. So the saponification value is inversely proportional to the mean molecular weight of fatty acid. In saponification reaction, so 1 mole of the fat, this is the 1 mole of the fat is reacting with the 3 moles of the KOH. On hydrolysis, it will be produce a glycerol and a soap. Nothing but a free carboxylic acid will be there. When this free carboxylic acid is reactive with the KOH, that time it will be produced the soap. The saponification value give the a complete hydrolysis reaction of the fatty acid fat. So how we are doing the procedure for saponification value determination is, take 2 grams of substance and place it in a flask with a capacity about 200 ml. You take one flask of 200 ml. To this we have to add 2 grams of the fat, and to this add 25 ml of 0.1 normal alkali KOH solution. So in the flask we have to take the KOH solution and our sample and reflection on water bath for 30 minutes. So we have to keep on the water bath for 30 minutes with occasional stirring or shaking, and cool it and add 1 ml of phenolphthalein solution. 1 ml of phenolphthalein solution. So when we add KOH, that time the KOH is reacted with the our fatty acid, and if any excess KOH will be present in the our flask, it is titrated with the 0.5 normal hydrochloric acid. So first, then you are recording it as a A. The value is reading as a A. Initially take the flask, to this add the our fat, to this add excess amount of KOH, and you can boil for some time. During this person time, what happened, the complete hydrolysis of the fat will be happen. During the hydrolysis the KOH is reacted. If any unreacted KOH or excess amount of KOH will be there, that is titrated with the HCl by using phenolphthalein as an indicator. So that time we are getting a reading that is recorded as a A. In the second time we have to do the titration without adding our substance or fat. Only we have to add KOH and phenolphthalein indicator and titrate it with the 0.1 normal HCl. This is called as blank titration. So that time you have to record it as a B. So this procedure called a back titration procedure. In the back titration procedure, excess amount of alkali is titrated. So the saponification value is determined by, first, the A minus B into 28.05 by weight of the sample we have taken. So how much amount of weight of the sample we have taken? The A is nothing but the volume of titrant consumed with the sample, and B is the volume of the NaHCl or titrant consumed without fat. In these two cases, we are adding KOH. The first case, KOH and sample we are taking. The second case, we are adding only KOH. We are omitting the sample. That time, how much volume of titrant or HCl is consumed, you have to read that one by using the given formula we are calculating the saponification value. So these are the some saponification values of fats and oils. So different fats, and what is the saponification value? The milk fat 210 to 233 and coconut oil 250 to 264, and these are the different fats with their saponification values. Next one is ester value. So it is very simple. The ester value is nothing but it is the one formula is there. The ester value is equal to saponification value minus acid value. What is meant by ester value? Ester is nothing but our fat is called as ester. The ester value shows the amount of alkali consumed in the saponification of ester, and is possible identify the differentiate the fats with these values. This ester value used for only differentiate the different fats. Depending upon the ester value, we can tell what is that fat, like that. So the exact definition of ester values, the number of milligrams of KOH is required to saponify the esters present in the 1 gram of substance. Nothing but it is similar to saponification only. But here the ester converted to free fatty acid and glycerol. The ester value is nothing but saponification value minus acid value. So this is a triglycerol fat is called ester. So here NaOH or KOH, alkali we are taking. So that time it will be form a soap and glycerol. So the procedure or method, same. You have to take the 2 grams of the sample and add 25 ml of 0.5 ml ethanolic KOH, and you have to boil for 30 minutes and the water bath, and add 20 ml of water and titrate with the excess alkali with the 0.1 normal HCl, and further add 0.2 ml of phenolphthalein indicator. The second time you have to titrate it without adding the sample. Same similar to the saponification method. So then we have to identify the saponification value and acid value. When you subtract the saponification value from acid value, that time we are taking the ester value. So these are the different constants and values used for analysis of fats and oils. The remaining values like iodine value and acetyl number, all these things we will discuss in the next class.